in radians and degrees. So radians are just another way to measure an angle, but it takes the radius of a circle into consideration. That's something, again, this is a building block lesson, so I'm going to show you how to convert, but I'm going to make it make more sense when we see a little circle next cycle. Okay, so today's little building blocks, we do need to be able to convert, and it's a pretty easy conversion. Just for now, just know that radians is just another way to measure the opening of an angle. Instead of degrees, it's called radians. Okay, and radians are in terms of pi, so you'll see a pi in all of the radian measures. So first, we're going to go from degrees to radians. Okay, so degrees to radians, and we're going to multiply by pi over 180, and that's our conversion factor. So that will bring pi into our calculation, so that way we have an answer that's in terms of pi. So the way we do that, just put the degree measure over 1. We multiply by pi over 180 degrees. So those degrees you can consider like they cancel out. So now we're out of degrees. And I'm just going to multiply these together so you can see it a little more clearly. So negative 120 pi. And just multiply the numerator over 180 and multiply the denominator. So that is the process. Then we just have to simplify what's attached to the pi. Okay, so all we have to do is then reduce that fractional part as low as we can. Okay, I know that 6 goes into both of those, and they both have 0, so I know 60 is going to go into both of those. So I'm going to divide them by 60. So negative 120 divided by 60 is negative 2. And that pi stays on top. And then 180 divided by 60 is 3, sorry. Okay, so I don't care how long it takes you to get there, if you're just dividing by 2s or 5s or 10s, just make sure you do get all the way down to the simplest one. Okay, so that's how we convert into radian measure. So 120 degrees is the same exact thing as 2 pi over 3 radians.
So is that the final answer?
This is final, yes. Yep, as long as it's fully simplified. So go ahead and do the same thing for number 2. Convert 75 degrees to radians for me. Again, just make sure you get it all the way down to its lowest form. And here that would be 5 pi over 12. Good? So that's going from degrees to radians. Okay, so now we're going to do the opposite way, which means we're just going to flip that conversion factor upside down. So when we're going from radians to degrees, multiply pi 180 over pi. By putting the pi in the bottom, it's going to divide out to 1 with the other pi. So then we'll be back in degrees because the pi will be gone. Okay, this one's a little bit easier because it's always going to be in like a whole number degree measure. So that means that whenever we multiply, like we're going to be able to just multiply the numerators and divide out the denominator. So I'll show you what I mean. Multiply by 180 over pi. And those pi's divide out to 1 because anything divided by itself is 1. So that's why those cross out. Okay. So now I can just do 3 times 180 divided by 4. Just 540 divided by 4. And feel free to use your calculator for that calculation. You should get 135.
Do radians have like a symbol?
No, so that's a great question. So if you don't see a degree measure, it's insinuated that it's a radian. Also, unless it's 0 radians, you'll always see a pi.
Okay.
Right? If it was 0 radians, then 0 times pi would be 0, so you wouldn't see the pi. All right, go ahead and do number 4. Convert that into degrees. The pi's again divide out to 1. That's why we can cross them out. And then negative 180 divided by 6 is just negative 30 degrees. Okay, so that's how we convert back and forth. That's something we'll use throughout, the next few months. So that's one important piece. But again, you'll see more about how it relates when we get into the unit circle next cycle. All right, so the most important thing is being able to measure an angle in standard position. Okay, we are now going to be measuring angles in a coordinate plane. So it's not like we just have a triangle and we're measuring that little angle. Now we're going to have an angle in a coordinate plane, and we need to make sure that we're all measuring it from the same spot. So there's something called standard position. Okay, so an angle in standard position always has its initial side on the positive part of the x-axis. That's our starting point always, no matter what. Okay, whenever you're drawing an angle, reading an angle, measuring an angle, you're always starting here on the initial side. Okay, that's why it's called the initial side, starting side. And then the direction of the opening will always be a curved arrow. Okay, that will tell you which way you're opening. And then that curved arrow will go all the way from the initial side to touch your terminal side, and that's where the angle ends. Okay, so this angle right here is the angle that starts here and ends here. It's this whole, whatever that degree measure is. Okay, so we just did radians to degrees, but today's lesson, since it's like our building blocks, will all be in degrees. So what we're going to be measuring today is how much is this degree-wise. So let's start to measure. Okay, so we can see here with letter A, we have an angle, and it's in standard position, okay, because the initial side, or where you start, is right here on the positive x-axis. And we want to measure how much this opening is from the initial to the terminal side. Okay, who thinks that they can tell me how much that angle measure is?
200.
Excellent, it's 200 degrees. Okay, so we know that because we know from one end of the x-axis to the other has to be 180 degrees. Right, it's half the circle, or you could see it as a straight angle. That's 180 degrees. And then this arrow keeps going to the terminal side, and they give us this little piece to tell us there's 20 more degrees. So we do 180 plus 20, and we get our 200 degrees. Okay, so a lot of this is like patchwork or piecemeal. You're trying to just break it down into pieces and then total them. Okay, sometimes they're easier to read than others, and sometimes they give you a part that's outside the angle to help you get what's inside, or like this one did, it's inside, right? So you just have to figure out, should you be adding, subtracting, whatnot. So for letter B, I want just the measure of this opening. So what is it? What do you think that?
75.
75, yeah, exactly, excellent. Because, again, we have 105 from here to here, and the rest will lead us back to the x-axis. So 180, right, is a whole straight angle, so this must be 75 to add up to that. Okay, now it's really important, I don't know if you noticed, but in the first set of examples when we were converting, we had negative angle measures, right? It might seem weird, why do we have negative angle measures? So angle measures can be negative depending on the direction that they open. That's all it is, it's just the direction of the opening. So if you have an angle in standard form, or standard position I should say, I always say standard form, but it's standard position. Okay, and if the angle opens up, then that is going to be a positive angle. So if the angle opens up, it's positive. Okay, so yes, that's counterclockwise, but it's a little easier to consider it is that arrow going up from standard position? Then it's positive. And vice versa, if that angle opens downwards from the x-axis, that's going to be a negative angle. Okay, so standard position, if the direction of the opening, if that rotation opens down like that, that's when you have a negative angle measure. Right. That's this angle. So you're just looking at the direction that initial rotation direction makes, like right off of that x-axis. Is it going up, it's positive. Is it going down, it's negative. Also helpful as we're trying to build like how big or total up how many degrees in an angle measure, is to consider, we're on a coordinate plane, there are quadrants, and it's kind of to consider fractional rotations. Okay, so we know that a circle, right, one full circle is 360 degrees, right? So if I were to draw that rotation, initial side, and then I'd have one full rotation, it would bring me all the way back, so that my terminal side would lie right on the initial side. Okay, so that is one full rotation. I went all the way around. Now, how many degrees do you think are in a quarter rotation? Just 1/4.
90 degrees.
90, excellent, right? A quarter is like a quadrant, right? There's 4 quarters here, so each one is 90. So that would be a quarter rotation, which is 90 degrees. Right, I could also be drawing the negative cases, but it's easier just to show these rotations in the positive case and know that they could also be opening downwards the same amount of degrees. Okay, we've already talked about half a rotation when we were looking at from one end of the x-axis to the other. Right, so half a rotation will bring us from the positive x-axis over to the negative, and that's our 180 degree rotation. How many degrees are there in 3/4 of a rotation?
270.
Excellent, 270. It's 3/4 of the way around. so looking at angle measures on a coordinate plane, literally the options are endless, because we can just keep rotating and rotating and rotating, go all the way up to positive infinity. So we could see angle measures that are in the thousands. We do work with angle measures that are that high, a little bit. And then you can also have the negative angles just rotating and rotating and rotating. So putting it on a coordinate plane, instead of being constrained to a triangle, it opens up lots of options for our angle measures. So like trig and the unit circle is considered cyclical because you can just keep adding rotation and adding rotation. All right, so let's measure some angles here. Okay, some are going to be easier than others, especially if they're not more than one rotation. So remember that we're only measuring the curved arrow because that's what's going from the initial to the terminal side. So how big is this angle that's drawn here in blue? What's the degree measure? Yeah, 70, right? If this is 20 and you know that a quadrant has to have 90 total in it, then this part of the angle must be 70. Right? And it makes sense because then if you add it back together, 70 plus 20 would give you your 90-degree angle. Now, number 2, we could be, some people's minds work differently. Some people like to look at the whole thing and subtract stuff out. Some people like to add up. But if you look, just so you can see another option, right? I could take this whole thing that the green goes up to and say, all right, total 270 minus just this green piece would give me the rest, right? So you could think of it that way. Some people, their mind goes right to it. Or you can just build up, right? This is how my mind would do it. I see 75 here. I know that 15 has to go in here to make 90. And then I know that that's 180, right, from one side to the other. So my brain just tends to build up, but you can go either way. You know, whatever comes easiest to you is the way I usually want to do this. See if you can do the next one, and then just hang tight for a sec. Be careful. I like to trace the curved arrow when I measure these, especially when they start to get bigger and go around rotations. But if you trace it, it kind of helps, because remember, you always want to start at your initial side. That's your starting point. And this goes down from your starting point. So this has to be a negative degree angle. Right? Everyone see how it's going down off that starting spot? If it's going down into the quadrant below, it's negative. So I just like to put the negative aside, and then I just add up the positive degrees, and then just tack the negative on. So I know from here to here is 90 degrees, but my angle still continues to that terminal side, which is 30 more. So I just total it up, and then make sure that I keep the negative with it. And I always look back and make sure that it was supposed to be negative or it was supposed to be positive as a second check. Because I can't give you partial credit if you get positive 120 degrees right here, because that is a totally different angle, right? Negative 120 goes down here. Positive 120 would be up here. It would have a total different set of x values, and the sign would be different, et cetera, et cetera. So you gotta be careful with your negatives. All right, and then lastly here, I see 270 if I look from there to there. All right, 3/4 rotation, I know is 270, but I have to go 20 degrees more. So this would be positive 290 degrees. Positive because when you trace it, it goes up. All right, so now when we're doing multiple rotations, right, I just like to do it in pieces. I'll go as far as I can in a full rotation to start. Right, so first thing I notice when I start is I'm going down. That's going to be a negative angle. Right? is one full rotation, so that's gonna be 360. Okay. And then the rest of my rotation is gonna bring me up to where that 20 is, so this piece must be 70, right? Because 70 and 20 is 90. So one full rotation, and then continuing on with the curved arrow, that's gonna be an additional 70 degrees. So that totals up to 430, and it's negative. See if you can do the next few, and I'll catch up. And you can check your work along the way, or ask me if you get stuck. So start at the starting point. I'm going to go around in full rotations. So for 6, if you didn't get 700, these are the pieces I broke it into. You can see the blue here is one rotation. The purple gets me 3/4 of the way around, so I did 270, and then I still had 70 more to add to it. So you should have with 700. All right. Continue with 7 and 8 if you haven't yet. Okay, so just be careful, like on this one, number 8, right? I did the 2 full rotations, get 720, and then here, I know there's 90, and then just 5 more degrees in here, because it gives us that this part of the angle is 85 degrees, so that sliver has to have 5. All right, so that's measuring angles. Now we're going to draw some angles. When we draw the angles, we're not using protractors, so we're just being approximate. We just want to be in the ballpark. Right? Did I go too fast? Did everyone see what I got for these two? Or do I need to re-explain any of that? Any part that confused anyone? No? Okay.
How come like for 8 you added 5 and then for 7 you added 30?
So see how this 30 is within the angle measure, because the curved arrow is through it. So I did 180, and then there's still 30 more to get to that,
Okay.
right? And then here I just added 5 because I needed that sliver, and they told me that that was 85. Alright. So let's make our coordinate plane. Okay, and then we always start with our initial side on the positive x-axis. Okay, so even when you're given like a worksheet that has arrows on it, the arrows are for the coordinate, for the axes. So you still have to draw your own initial side, right? And then we have to make sure we also draw the terminal side and the curved arrow. Otherwise, you haven't made an actual angle. Okay, I don't just want to see like I don't ever like teach it this way, but somebody will just suddenly be like, all right, that's my angle. I'm like, well, you're missing the initial side, the terminal side that like actually fit that angle, right? So you just want to make sure that you're drawing initial side, curved opening to the terminal side. So when I think of 36 degrees, I think of the fact that it's pretty close to 45, and 45 is going to cut right through the first quadrant. So I'm just going to do a little bit less than cutting through the first quadrant, right? Because 45 is half of 90. So I'm just going to go, geez, that was kind of close to 45. But we're approximating, so that's fine. Let me just make a better model for you to follow. Right, just a little bit less. So that's good. So initial side and terminal side are there. And then we need the curved arrow, just like that. So that's enough for me. You don't need to put in like 54 degrees here to show that you know that this is 36. You can, but that is enough for me. I can tell that you were trying to measure a 36 degree angle. So for 315, if I think about, the full rotation, that's 360. So I might want to use my calculator here and do 360 minus 315 so that I know like how many degrees are not going to be included in this angle, right? Or you could go up in 90s, like however you want to do it. But I would do 360 minus 315 and you'll get 45 degrees. So you know that there's 45 degrees left over at the end of the angle that's not part of yours. So I know that draw my initial side and my terminal side is really going to break right through as close as I can to half. And hopefully you can see how important the arrow is here to make sure that you're clear that you're talking about this part of the angle instead of that part. Right, so you always need that curved arrow. Alright, so go ahead and try to draw a negative 150 degree angle. Remember, we always start with the positive x-axis. So I know 150 is 30 degrees away from 180, right? So if I'm opening the downward direction, I know that I can like just make it again a little less than 45, and that should do it. That's fine. Just make sure you have that curved arrow to show it's opening downwards. All right, so these next examples here, we're trying to determine what quadrant the terminal side of the angle are. All right, so we're going to sketch just like we did right here. And then we're just finding the terminal side of the angle and writing down which quadrant that's in. So, a little review. The first quadrant is always that top right quadrant. That's where everything is positive. Your x coordinates and your y coordinates. So you're positive here. And then it moves counterclockwise. So your second quadrant, top right, top left. 3 is bottom left. And 4 is bottom right. If you don't write your numbers in Roman numerals, I will not take off points, don't worry about it. But that is the proper way to write it, so that's the way I'll write it. Okay, so we're gonna, for example 3, do exactly what we did in example 2, draw it, and then go find that terminal side and write down what quadrant it's in. This isn't my best. It's not my best work. It's really not a big deal, but that's not good either. That's fine. Okay, so draw the whole angle, because that is part of the question. Okay, sketch the angle. And then you can see that my terminal side is in the 3rd quadrant. So this would be my answer, just like that. See if you can come up with letter B.
Did you say you will take points off or not?
I will not.
Oh.
No, don't worry about that. Okay, so my first step here would probably be to subtract 360 out of 550 to see how much more I have to go after I do a full rotation. All right, it's probably going to be your best bet. So if you subtract 360 from 550, you're going to get 190. So I know I've got to go a full rotation and then a little bit more than a half rotation. Okay. Full rotation brings me all the way back around. There's 360. And then 180 brings me the other side. And then just a little bit more for your 10 degrees. That one randomly was 3 again.
So it's where like the
Yeah, the terminal side. All right, so last set of examples are coterminal angles. These come up quite a bit, when you're working with certain problems and you want to make the problem more simple. You can add or subtract a rotation to get the number to be within something that you're more comfortable using, and you'll see that next cycle. So coterminal angles are angles that end in the same place, right? They always start in the same place because they're in the standard position, but they end in the same place as well. So for that to happen, you just have to go 360 degrees in either direction, because won't a full circle bring you right back around to where you started? That's what a full circle does, right? Wherever you are, if you go 360 degrees, you're coming right back to that spot. So coterminal angles, it's as simple as you're either adding 360 or you're subtracting 360. You're always adding or subtracting a full rotation. So all you need to do is figure out how many times you have to add or subtract 360. And to do that, you just read whatever the constraints are in the instructions of the problem. It could be given in multiple ways. This one's saying find a positive angle less than 360. So positive means 0 to 360. So when we're starting with 420, and I need it to be between 0 and 360, that means I have to subtract a rotation, right? I need to get it within this constraint, so we subtract 360 here. So 60 is considered a coterminal angle coterminal to 420. Okay, let me just really quick show you why that works. Alright, say I measured this as 60. Well, if I drew a 420 degree angle, I go 360 and 60 more. coterminal. It's the same angle, it's just the rotations away. That's why we always add or subtract 360. So for letter B, I want coterminal to negative 120, but it has to be positive and less than 360. If it's starting as negative and I need it to be positive, my only option is to add 360, right? Because I need it to be a positive number. Okay, so if you get 240 degrees. Does that fit in my constraint? It does, right? It's positive, it's less than 360. So these two angle measures, negative 120 and 240, are coterminal. All right, different constraints. Now, this next example wants me to find one positive and one negative for each. Okay, so there's two things we have to find, but we can have all different answers depending on how many rotations we added or subtracted. So in this type of problem, you know, if you had something different than what somebody next to you calculated, you could still be right. It's just depending on how many they added or subtracted. So I'm finding one positive angle to 36, right? And I know I have to add 360 to it, right? That will give me my positive coterminal. And then just go back to the original 36, because I still need to find one negative coterminal angle. So in this case, I'm going to subtract 360. I have found one positive and one negative coterminal angle to 36. Okay, see if you can do that for the next two. Make sure you keep going until you get your answer in the constraints, okay? So sometimes you have to add or subtract more than one rotation. Just keep going until it gets positive or negative, depending on what you need it to be. Could have totally different positive versions here, because you could have subtracted and still been positive. So again, these are kind of like suggested answers. That yours don't have to match mine as long as yours is 360 degrees away in rotations. So I just added just to be consistent. Like if I add every time, maybe I'll always have a positive. So that's my positive case. I have to work harder to get the negative one. I believe I have to subtract 360 3 times. Yes. And that will get me to negative 225. Okay, so just keep subtracting 360 until it gets to be a negative number. Alright, and then last one here. Add to get my positive case. And then I'll subtract to get the negative case. So that's all coterminal angles are. right? Just adding and subtracting rotations. All right, that's it. So